welcome back. Today we are going to solve a problem which is from portfolio management, and this is from December 23. Right? Okay. Following are the details of the portfolio of BOI Limited. They have given the share name, portfolio weight, beta. Okay, portfolio weight and beta will get the portfolio beta. Expected return have been given. Total variance is the total risk. Uh, Total risk of each security have given. Standard deviation of market given. Okay, and then covariance of each securities have been given, and then they have asked to portfolio beta, residual variance, unsystematic risk, portfolio variance, total risk using Sharpe index model, and portfolio total risk under and modern portfolio theory. Easy problem only, but the thing is they have tweaked the problem in different manner. Right, let's quickly solve the problem. Portfolio beta, it's a very simplest one. Okay, share weight beta, weight into beta, right? BG BZ DN, what's the weight? 0.3, 0.3, 0.4. What's the beta? 0.4, 1.2, 0.5. Let's multiply both of this. 0.3 into 0.4, which is 0.12, 0.3 into 1.2, which is 0.36, 0.4 into 0.5, which is 0.2. Total is 4 into 0.12 plus 0.36 plus 0.2, which is 0.68 is the portfolio beta. We found the first one within a span of minutes. Okay. Yes, next one, residual variance. What is residual variance? Residual variance is, first, what's the total variance? Total variance is equal to systematic risk plus unsystematic risk, right? Residual variance is nothing but the unsystematic risk, and they've asked for the unsystematic risk value, right? Okay, what's the unsystematic risk formula? Which is beta of the portfolio square into sigma market square. This is the formula. What are all the information they have given in the question? See, total variance given, market portfolio returns have been given, and beta also we found. Yes. Okay, so now residual variance is equal to total variance minus portfolio beta square into sigma market square. Okay, what's this? BG BZ DN, right? What's the total variance? 0.015, 0.035, 0.020 minus portfolio beta, which is 0.68, 0.4624, 0.4624. Sorry. We have individual stocks now. We have individual stocks beta. So 0.40 square minus 1.20 square minus 0.5 square whole square into sigma market square. We have a sigma market, which is standard deviation market. They have given 14%, 0.14 square is 0.0196, right? Okay, 0.0196, 0.0196 into 0.0196. Mark it, doesn't change, right? So 0.4 into 0.4 square, 0.16, 1.2 square, 1.14, 1.44, 0.5 square, 0.25. Total this 0.16 into 0.0196. Okay, plus 0.015, which is 0.012, right? 1.44 into 0.0196 plus 0.035, which is 0.0067. So we'll keep this as 18. Okay, then 0.25 into 0.0196 minus plus 0.020. 0.0151. So we found out all the residual variances. The third one is portfolio variance using Sharpe model. What Sharpe is telling, total variance is equal to systematic variance plus unsystematic variance. Okay, what's the systematic variance? Beta square into sigma market square plus unsystematic is we already found, right? Okay, and we also we have been given with weight, so we'll include the weight also, right? Okay, what's the beta? Portfolio beta is 0.68 square into sigma market, which is 0.14 square plus sigma e term, which is residual term, which is 0.0118 into weight. What's the weight? Weight is 0.3 plus 0.0067 into 0.3 plus 0.0151 into 0.4. Yes, here we have to square up the weights also, right? .68, 0.4624 into 0.414, 0.0196 plus into 0.0118, 0.0067 to 0.3 into 0.0067, which is 0.00151. 0.004081. Then 0.4624 into 0.0196. It comes to 0.013 is the portfolio variance using Sharpe model. We'll do the same thing for portfolio variance using Markowitz, which is modern portfolio theory. Here three securities are there. What do we need to do is a square plus b square plus c square. A plus b plus c the whole square formula we have to apply, right? 8 into a into sigma a the whole square plus 8 into b into sigma b the whole square plus 8 into c into sigma c the whole square plus 2 into weight of a into sigma a, weight of b into sigma b into r a b. 2 into weight of b into sigma b into weight of c into sigma c into rbc. 2 into weight of c into sigma c into weight of a into sigma a into RAC. That's what the formula is. We'll just apply the values here. Weight of A is how much? 0.3, 0.3, 0.4, right? Yes. What's the standard deviation? 0.015, 0.035, 0.020. Into covariance of BG and BZ, which is 0.030, plus 2 into 0.3 into 0.035 into 0.4 into 0.020 into 0.050 plus 2 into 0.4 into 0.20 into 0.3 into 0.015 to AC is, which is 0.020. Okay, let's total this up. 0.3. Okay, 0.3 into 0.015, 0.3 into 0.035, 0.4 into 0.020, 2 into 0.3 into 0.15, 0.3 into 0.035 into 0.030, 2 into 0.3 into 0.035 into 0.4 to 0.020 into 0.050, 2 into 0.4 into 0.020 into 0.3 into 0.015 into 0.020. Actually we have to change the formula. I have made a mistake here, sorry. Let's quickly change the formula. I made a little issue here. Okay, weight of A into sigma A the whole square plus weight of B into sigma B the whole square plus weight of C into sigma C the whole square plus 2A weight of A into weight of B into covariance AB plus 2 weight of B into weight of C into covariance B C plus 2 into weight of C into weight of A into covariance AC. I just misunderstood as covariance as correlation, so my mistake. Let's quickly solve the problem. Weight is 0.3. We already have a sigma square values 0.015 plus 0.03 square into square value 0.035 plus 0.4 square into 0.020 plus 2 into 8 0.3 into 0.3 into 0.030 plus 0.3 into 0.4 into 0.050 plus 2 into 0.4 into 0.3 into 0.020. Now let's quickly sum it up. Into 0.37 into 0.4 into the answer is 0.0299. That's it. Thank you.